Okay, with this one, I'm going to tell you the answer. And then I'll show you why it's true. Okay? So this is the case here. And I'm going to show you an informal way of seeing why this is true. And it really comes down to filling out these tables. All right, so let's look at this thing here. Okay, actually, let's see. In the previous video, you saw that the natural numbers had the same cardinality as the integers. Now in this one, see, I'm gonna fill out a table that shows that the n cross n has the same cardinality as the integers, and so then together we can put those together and get that these are the same. All right, so now starting with this thing. Okay, so in a previous video, let's see, from functions 4, we saw that the cross product of z plus, or the positive integers with the positive integers, is equal to, has the same cardinality as just the positive integers. All right, and we saw that like so. I'm not going to be super formal here. All right, so we have this the dots, right, and then this is z cross z is all these dots going out to infinity, right, like so. And then z plus was 1, 2, 3, 4, 5, dot, 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 like so. And if you remember, okay. And so then we had a function from a one-to-one and onto function, a bijection from z cross z, z plus crossed was z plus to z plus, some function f. Now you'll notice that that what I have here is the function table for that function from the cross product of z plus with z plus to z plus. And let's see, 1, 1 went over to 1, over 2 up 1 went over to 2, over 1 up 2 went over to 3, and so on, like so. Okay, maybe you okay, now but what we're concerned about is we want to look at n cross n to the integers. So defining a bijection from n cross n to the integers. All right, now I could do this formally, but that's not the point I'm trying to show you right here. What I'm trying to show you right here is that really with these types of infinities, and we'll see later that there are different types, but with these types of infinities, it's all about filling out the table. Can you fill out a table? Okay. All right, so z plus crossed with z plus, that's all the positive integers, all the dots that made up in the first quadrant that have positive integers, right? The ones I've shown here, right? But n cross n, right? There's a little bit more. It's all of these with z plus crossed with z plus, but there's also these ones along here. Something like that. Okay, as you know, this one here is 0, 0, right? This one is 1, 0. This is 2, 0. Then this next one is 3, 0, and so on. This one over here, this one here is 0, 1, over 0, up 1, over 0, up 2. This is over 0, up 3, like so. Right, and I'm going to match these up informally just by filling out this table with the integers. Okay, so I'm going to put 0, 0 with 0. Think that makes sense? Okay. All right. And so now I'm going to put 1, 0 in here, and then 0, 1, and then 2, 0, and 0, 2, and then 3, 0, and 0, 3, and I'll continue like that forever and ever and ever. And then what integers am I going to match these up with? I've got -1, -2, -3, -4, -5, -6. And that defines my bijection. Now you might say, hey, now, how do you know that's a bijection? Well, just think about what we've talked about already, right? Are each of these different? Well, yes, they are. How do we know that? Well, these we already know are different because this we've already proved, or this function right here, we've already proved, is a bijection, right? So now the way I've filled all these out, right, these are all different, right? You can see that they're all different. Okay, there's no D and E's, right? Because everything's associated with some integer there, and all of these are different. So it's 1 to 1. So it's 1 to 1. It's on to. And so therefore it's a bijection. So therefore we see that in fact this is true. Okay, and so now let's see, we know that that's true. And we also know from the previous video that this is equal to the cardinality of the integers is equal to the cardinality of the natural numbers. So putting those together, remember A, B, B, C. So if A is equal to B and B is equal to C, then A is equal to C. That proves that that's true.